I'm Isabelle. Nice to meet you, everyone. I'm the field CTO and one of the co-founders of a company called 42 Crunch. And I'm here to talk about, so we got a great session, 3 sessions now on different type of attacks and what we're doing. So I'm going to get maybe more into some examples. We usually like to see how others failed, right? It's always interesting to see. So that's what we're going to see, some examples of attacks, of breaches. Some of them are real breaches, like data got lost. Others are just friendly hackers who went on systems and found problems and reported them and made some good money out of it. We'll see that, okay? All right, so let's get started. So really, there's a lot of different problems, as you may imagine. We've seen some examples today. SSRF coming back on APIs is important. So at 42 Crunch, we do something called APIsecurity.io. This is no marketing, and it's not talking about products. I have even competitors here in the front that can vouch for that, right? It's all about education on API security and understanding those breaches and tools and books and things to help you, right? But for the past, so we've done this for 4 years. It's our 4th anniversary already. And pretty much every single week we have something to talk about. So there's a lot of things happening out there. A lot of problems happening out there. So why is it such a problem? Why are APIs such a problem, right? Why do we see so many issues? And I'm going to say something that Inon talked about a bit this morning, which is an architecture change, right? So whenever we're exposing APIs, what do? In the end, what we do is we open an avenue into the data that we have in our data centers or processes, right? That's pretty much what we do. What we used to do before was we would have some kind of a controller layer that would filter and massage that data and information before we would be creating, merci beaucoup, a representation in it and then send back some JavaScript and HTML to a client. Now what we do is we expose APIs and basically we create very rich applications that will go and consume that information and data, right? Which means that whatever control, if we can call them this way, we would put at the client level, basically don't really matter, right? Because I can go straight into the API and bypass any of that. When we'll talk about validation, we'll talk about this. Now, I like to explain this way in terms of architectures. A lot of people are asking us, so why, and if you've seen Mark O'Neill's presentation this morning as well, it's like, all right, I already have plenty of stuff in place from a standard security point of view. Why do I need something else? Well, the reason mainly is because traditionally, what we've been doing from a security standpoint is building walls around ourselves, right? If you think that that little city here, a lot of French people in the room. Do you know what that city is for the French people in the room? Ah, come on. Okay, this is Blaye, Côte de Blaye, Bordeaux, all right? A lot of wine in there. All right, so it's one of the cities that was built by this very famous French architect called Vauban, right? And traditionally what we've been doing is building series of walls. So if the first wall would fall, then it would be a second one, and then a third one, etc. Right? And if you were passing all the walls, then you will get to the heart of the castle. Now, whenever you do APIs, you do this. This, you know where that is. Right? That's easy enough. All right. So every time you create an API, what do? You create a new avenue getting to the Arc de Triomphe. Right? So what do you have to protect now? So it's not about protecting the borders anymore. There are no more borders, as we were saying this morning in the session just before. Right before we were saying it was we will be a wall and will prevent any outbound connection to go, right? Now, if you do that, you're not consuming any external APIs anymore. So it's really hard to do allow list of where you're allowed to go or not. So this is really the image you have to keep in mind of what you're doing with APIs is very different. The next thing is we've really equipped the developers, all of you. How many people are here are developers in this room? Let's see, quite a few, okay. So we've given you frameworks, we're giving you a lot of tools to go as fast as possible, right? You can point to a database, click on the button, and you get a REST API. Or, well, I wouldn't personally call that a REST API, but that's okay. It's a design thing. But you get an API that you can expose very quickly. Then you push that code, some magic happens in the CI/CD, and boom, it ends up in a cloud somewhere. Right? So it's very fast, very quick, very easy for a developer to do. Now, our poor AppSec people, any AppSec people in the room? Security? Well, you, okay. All right, a few people security are not equipped with the same tools. Not going as fast, you know? I was in a presentation some weeks ago where somebody said now there is like 500 developers in a company for 1 or 2 AppSec people, right? So you have 500 developers writing APIs like crazy, right? And you have 2 poor, sweating AppSec people in the front trying to do something about it, which means we have a scaling problem. That's really what I want to say here, right? We have a really scaling problem, how to scale security. Because not only do we have a lot of them, we also have resources issues. And finally, almost, right? A little bit like 10 years, 15 years ago, like testing with this thing we were doing at the end of the life cycle, and we would be compressing and compressing so we would finish the code, right? We're in the same position with security today. I still see a lot of people just considering security very late in the life cycle. And then we wonder why we have a problem, right? Once we got, you know, some issues from a security standpoint. So really have to think about security much earlier in the life cycle. Another thing that we see a lot, you know, is design decisions. So we see, you know, there's a lot of things that you will have to think about when you create APIs that happen at design time. Not what's what I'm saying when you point to a database and you generate a REST API. For me, yeah, you have a missing thing in here, which is called design, right? What is this API? What is it going to do? Who is going to access it? What data is it going to expose? All those questions you need to ask yourselves before writing something, because that's how we get problems, right? Because you're going to create something, maybe it's just for yourselves, and 6 months from now, it's going to become an open API everybody in the internet can actually talk to, right? Somewhere along that path, some design needs to happen, right? And much like this house, which has a little problem, right? Some design decisions, once you're really advanced in the life cycle, are going to be really hard to undo, right? We get this from customers all the time, which is, well, we know, right? We're going to publish this API. It has a lot of problems. We know. We're just going to cross fingers, nothing happens, while the developers actually try and fix it for version 1.2, right? That's what happens, all right? But I hear you, right? This is hard. That's what I hear from everyone as well. You know, look at just what Jonathan explained right now on SSRF and all these little things you have to put in your code, right? Just for that problem, which is one of the 10 problems, right? So education for the development community is going to be really critical here, right? And whatever we can do to help developers do this better and detect those problems earlier is where our salvation, for me, is going to be, right? Now, I'm just going to give you a framework and then we get into those attacks. This is something we just put together to explain a little bit. There are things you will have to do all along the API lifecycle, right? There are things you have to design. You have to decide at design time, at development time, you know, how is your governance defined? So all of these are different aspects of the API lifecycle that where you have to do some work in order to cover API security at large, okay? So what I'm going to do now is show you those attacks and map this to this framework, so to give you ideas of what could have been done, right, to address this problem at each part of that life cycle. So we'll start with a shipping company, right? So this happened about a year ago. Just show you the picture here. The idea is there is an API which allows you, if you have a parcel ID and a zip code, right, of where the person lives, just with these 2 pieces of information and nothing else, no authentication, nothing else, right? You can get all the information about that parcel, which includes, well, the data about the person who's going to receive that parcel and some very delicate information and PII information, such as where they live, their emails, their phones, and all this kind of stuff, right? So what did the hacker do? They basically reversed engineer that image that you have here on the left and found the information behind, looked, basically based on the image itself, were able to deduce, if you want, the postal code from that image, and then do that association between the parcel ID and postal code, and then bingo, you call the API, you get all this information you see here on the right, okay? That's what happened. So how do I protect myself from this? The problem is, there's clearly a design time problem here on, okay, what's going on with the data which is going to be accessed and how. There's clearly some PII, delicate information, sensitive information here, which is going to be returned by this API, although there is absolutely no authentication on that endpoint, right? So that's a major problem. Something, this relying, security by obscurity is always something we talk about. It's not because it's hidden here, right, that people cannot see. This is also what I see when people think that an API is hidden because they are the only ones to use it, like from a mobile app, for example, right? If you use an API from a mobile app, people call this a private API. No, it's not. It's public. It's very public, right? Any of those guys here are going to tell you. So there's a big difference between an open API and a public API. Anything which is on the internet is public. So any obscurity is not going to work here, right? So testing. So obviously there's big problem today on testing APIs and see what happens if. Right? As I always say, we're always good at testing the happy path, right? What you need to get good at is testing the hacky path, which is what happens if? What happens if I'm sending some wrong data? We were talking just before about sending an option, call to an API when it's not planned, or a delete on an ID where you're supposed only to be able to retrieve it. Have you tested that? Do you know what happens in your APIs if you're sending a wrong verb? Do you know how your API is going to react if you send it an integer instead of a string, right? That's what hackers do. They'll just go and play with it until they get information they can pull from that thread, right? So all this information you're leaking is, interesting one for them. Campus access control. This is actually a cool one. So this is a bored or tired student basically in a campus, and they have this application that allows them to access their dorm rooms, right, where they live. And that application is really bad, and they're tired of it failing and everything, so the guy just decompiles it, finds the APIs, right, and then realizes that what he can actually do with one of the APIs, again, no authentication, no authorization in there. If he knows let's say, the coordinates of the room where the door is, right, where the door is, and just puts the name or the ID of the student who was supposed to live there, it will open the door, right? No validation whatsoever, which is one of the key problems, right? That the ID I'm actually putting, right, is actually myself. I'm not trying to open the door of somebody else, right? So that's a big one of these function authorization problems that Inan was talking about, maybe making sure that I'm allowed to actually call this function, although I'm not the person who actually lives in that dorm, right? That's pretty much what that problem actually was. Now, how do we prevent ourselves from this, right? So obviously, from a design perspective, I should not be able to fake my location, which is really what this guy did. It discovered by luck, really, that he could fake the fact that he was actually in front of the door trying to open it. He could have been in Paris and trying to open it, and it would have worked, right? So that's the first thing. So it's not really validation here of your location. So the student ID thing, you say, well, what's the problem here in terms of the validation? So it is very easy. What they've used actually to identify the student and open the door is basically or their email or their student ID, which is very easy to find, right? So you need to make that work a bit more difficult so that you can actually guess what the ID of that user actually is. So you cannot enumerate or fake it or build it manually or through a script, as we've seen before from Eric, okay? Testing, again, hacky path again. What happens if? What happens if I'm trying to open the door with the wrong ID, right? So it's really a testing problem again. So there's a lot of those problems that could really be avoided if we were thinking like a hacker in what happens if, right? So we need to get in that habit of like become paranoid, basically, on what can be done on top of our APIs, right? So the other thing here on the governance part, what really was bad in that leak, as Eric said before as well, it's not a matter of if, it's a matter of when this is going to happen to you. And as a company, it is very important you have a responsible, a program to answer responsibly to hackers who are actually trying to help you, right? And found some problems. In this case, it's a student, but he tried to go to the company who actually owns those dorm locks, right? And they totally ignored him for like 6 months. And he had to go to TechCrunch, basically, to an external technical article company on site. And they're the ones that make the link to the company. But it took 6 months. And the main problem is that lock is used on like all the main universities in the UK, right? So that problem has been there for a very long time and nobody addressed it. So the way you address this kind of issues is actually also very important. Well, this one you may have heard about, and you may know the name if you live in the UK. This is a micro brewery, right? In sympathical thing. So what they did, I'll show you the picture, you're gonna see that. It's like, why they did this, I have no idea. But basically, you would connect to the app will give you a token, but the app had the hard-coded token that it was using for every single call. Same token, all the calls, whoever calls it, doesn't really matter. You can see it here, Y9A, blah, 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 right? So every single thing. So how did they find this? Very easy. Again, security by obscurity. Don't think people cannot reverse engineer an application. It is very easy to do on Android and all that stuff, to just decompile the code and find these. They are very easy to find. What was the impact of this? It was actually very interesting. Like once you had this token, that was of course an admin token. So you could do absolutely anything with that token. You could generate forever free beer on the application. So you could generate discount codes forever. So one of the, they don't really know if this happened or not, but yeah, maybe it did, that somebody just generated free tokens for free beer for the rest of his life using that thing. And the other thing, as you can see here on the right, is when you had that token, you have a lot of information again about the user. So this is the data leakage problems that we see a lot in APIs. For me, one of the key things about protecting APIs is we've been very concentrated in security on filtering data in, right? With API, it's also very critical to look at the data you return, right? Am I returning sensitive data? Am I returning more data than I should, etc.? So you have to be very careful about what you return as well, not just what you accept in terms of validation. Okay, and I'll finish with this one, which is actually so I wanted to show you this bug bounty. This is a textbook for this BOLA problem, right? So at a very high level, this is a Bitcoin exchange platform. You start basically a buying of something between two accounts. So you start the transaction with an account that has money, right? And with that money, that account that has money, you want to buy something. And in the middle of that transaction, just before you buy something, you change the account ID that had money by one that does not have money, right? And you still buy. Because basically you can buy whatever you want for free. Which is why this gentleman who found this got a nice bug bounty of $250,000. Right? It was they fixed the problem in like 2 hours. It was just a matter in that process to make sure just before you bought, that the original account ID was still the same one, 5 steps later in the transaction, right? Textbook BOLA stuff. All right, I'll stop on this one, and now, because I'm late, I'm gonna go to that part. So just to give you the key message behind this. So what I see really is there's a lot of problems that could be avoided if we really were more proactive about security, right? Rather than reactive. So it's all about, for example, testing those hacky paths. So think like a hacker, think like what is going to happen if, right? So do more than just testing the path that works and gives me a 200 OK, but test all the other parts of the API as well. And the OWASP Top 10 that Inon talked about, for me, is a framework for you to kind of create a program, if you want, in your company on top of, well, somebody has done all the work for me of finding what are the top priorities that I should be worrying about, right? So that gives you that framework for where do I start, basically. That and the risk associated to your APIs. You should know how risky your APIs are. Are you building the weather channel, or are you building a banking application? The risk is not the same, right? Done. And the last part, we talked about this at the beginning, is automation, right? So we have very few AppSec people. We have hundreds of APIs. There's no way you're going to do all the security manually. It will never work, So invest in automating those tasks. Should it be deploying policy, should it be testing, all of that should be part of your CI/CD and happening every time a new API pops up somewhere, right? So automation is going to be a key investment in the next years in order to enhance API security. Thank you very much for your attention, and I'll be answering questions if you have any. Any questions?
I'm just curious. I've been curious for a long time. How do you keep on track with so many API issues and maintain the newsletter, the APIsecurity.io?
How do we
How do you keep on track with all the API security issues, and basically publish every week? I think.
Every week, yeah.
Yeah. How is possible to do it? What is the trick?
How do we do APIsecurity.io? We have someone dedicated to that, really. So who has a lot of input data from all over the internet, compiles it, and builds the security newsletter from that. Yeah, it's a lot of work.
Yeah.
It is a lot of work, but I hope it's useful. We have more than 15,000 people.
Yeah, at some point, my boss told me, "Oh, can you build something like API security?" And I'm like, "I don't think so."
Yeah, it's a lot of work, but we've been starting that quite some time ago.